About this style question. This was the end of the assignment. Yes, or I guess Thursday's assignment, 4.1. Question 23 asked you something like this. We did an example on Thursday over it. But that was a special case because it gave you a right triangle. In general, right triangles are actually very uncommon to be provided in comparison to all the triangles that we ever have. Right triangles are a small category of them, right, or a small section of them. So how do I address that problem if I'm not provided a right triangle? Okay, they're going to ask you, they're going to say if triangle ABC is congruent to triangle RQS, find RQ, QS, and RS. Okay, and they're going to give you then some ordered pairs for A, B, and C. Well, if I want to find distance AB, I can do that. Find BC, find AC, I can do that. But I don't have ordered pairs for R, Q, and S. So the idea here, the geometry that we're trying to learn that would be new geometry is the idea that if I know that these two things are congruent, okay, if ABC is congruent to RQS, then AB is going to be the same as what other distance? RQ. Okay, so when asked to find RQ, I'm really just going to find AB and then make that link, right? When I look at BC, what's BC equal to? QS, and then AC is the same as RS. So if I can understand that link, that's the new geometry that we've been talking about. Okay? Now, in order to do this, in order to find the numerical values, I have to rely on a little bit of the old geometry, which says that the distance formula between 2 points equals the difference in my x's squared plus then the difference in my y's squared. Okay? So I'm going to do this for AB. I find distance AB. Okay, so I'm going to focus on A and B, those ordered pairs. Okay, so subtract my x's. What's 1 minus -5? 6. Now let's square that. Do the same thing with my y's. What's 4 minus -1? 5. And I'll square that. So that gives me 36 plus 25, which ends up being 61. Okay, is that prime? You get 61 prime. So that's fully simplified. So AB is root 61, but that's the same thing as RQ. Okay, and now I found that value. Does that make sense? On Thursday, the example we did, you can kind of circumvent that work or go around that work by understanding that the distance formula is the same thing as the Pythagorean theorem. And that only works sometimes. It only works when I have a right triangle. The process that you went through on Thursday, if you go back to that video, only worked because I had a right triangle. And if I get a non-right triangle, how do I address it? This is the way you do that. Okay? So now I'll do one more of these. Let's do BC. So distance BC. Let me get these axes out of here. Distance BC. Now I'm looking at point B and point C. We'll subtract the x's. So it's -5 minus 2. -7. Square that. And then I go -1 minus -3. 2. Square that, right? So then I get 49 plus 4. So root 53. And that would be the distance for BC. So it's distance for QS as well. Because those two triangles have to be congruent, so their corresponding segments have to be the same length. And we do the same thing for AC. We would use the points, obviously, A and C then. Is that all right? Now, when you do that subtraction, it doesn't, like we said before, it doesn't matter the order. Okay, I went -5 minus 2 to get that -7 there in that last distance. You could have gone 2 minus -5 and got 7. When I square both those, 7 or -7, I get 49 both times. Okay, so don't get hung up on the order in this case when we do a subtraction because we are going to square. But hopefully you kind of appreciate this type of problem and realize this little argument here, is the only thing that is new to the process, okay? In addressing how to find RQ, QS, and RS, we're using old geometry, which hopefully by this time we've got understood and we can use it anytime we need to. And that's going to happen over and over and over again throughout the year. They're going to give us theorems and postulates that produce a small relationship of equality. And then they ask us, can you model that using the distance formula? Can you explain that in this problem using the distance formula, using old geometry? Does that make sense? All right, and that's going to happen a lot, especially in the next handful of chapters, okay, 2 or 3 chapters. So we'll make sure that we're fully understanding that distance formula. If you're starting to get questions, guys, in Math Excel that have ordered pairs like this, always say you don't know what to do. In the back of your mind, my hopes are distance formula. Ordered pairs link you to distance formula in geometry, okay? And about 99% of the time, they'll get you in the right direction.